Deep within our amazing planet Earth, it is incredibly hot. This intense heat is strong enough to melt solid rock. When rock melts like this, it becomes a thick, flowing substance. We call this molten rock magma. Sometimes this fiery magma pushes upwards with great force. It searches for a way to escape to the surface. When it finally bursts out, we witness a volcanic eruption. It is truly one of nature's most spectacular and powerful sights. Imagine, if you will, a majestic mountain, seemingly peaceful for many years. Then quite suddenly its top might explode with a tremendous sound. Billowing clouds of smoke, ash and gas shoot high into the atmosphere. Rivers of glowing, molten red lava begin to flow. They carve paths down the mountain's steep sides. The ground beneath your feet might shake violently. The sound can be deafening, a profound roar from the planet itself. These eruptions are not just destructive events, they are also incredible acts of creation, showing us the Earth is alive. The sheer scale of volcanic power is often difficult to comprehend fully. Some eruptions are relatively small, perhaps gentle streams of lava. Others, however, are enormous, truly world-changing events. These colossal eruptions can throw out vast clouds of fine ash particles. These ash clouds can travel all around the globe, carried by winds. The energy released in such an event is immense. It is far greater than any explosion humans have ever created. Volcanoes serve as a stark reminder of how powerful nature can truly be. Volcanoes are not only found on the land we walk upon. Many of these fiery giants are hidden from our view. They lie beneath the deep blue waters of our oceans. These submarine volcanoes erupt silently, or perhaps not so silently, in the dark depths. They continuously build new seafloor, adding to Earth's crust. They also create vast underwater mountain ranges, unseen by human eyes. Some even grow tall enough over millennia. They eventually break the ocean surface, forming entirely new islands. The Earth's surface is in a constant state of flux, and volcanoes are a major dynamic part of this ongoing change. When a volcano erupts, it releases incredible amounts of material. Molten lava flows out, and clouds of ash and rock fragments are ejected. This material does not simply vanish into thin air or water. As the lava cools, it solidifies and becomes hard rock. The ash settles and compacts over time. Layer upon layer of this volcanic debris builds up. This happens with each successive eruption over thousands, even millions of years. Slowly but surely, a distinctive cone-shaped mountain can form. The iconic Mount Fuji in Japan is a stunning example of such a volcanic mountain. Not all volcanic mountains, however, share the same appearance. They come in various shapes and sizes, telling different stories. Some are impressively tall and steep with symmetrical cone shapes. These are often called stratovolcanoes or composite volcanoes. They are built from alternating layers of hardened lava flows, ash and volcanic bombs. Others are much wider and have gently sloping sides. These are known as shield volcanoes, like Mauna Loa in Hawaii. They are formed by very fluid, runny lava that spreads far from the vent. The shape of a volcano gives us clues about its eruptive history. The creative power of volcanoes extends to the oceans as well. As we have seen, many volcanoes begin their lives on the ocean floor. If an underwater volcano continues to erupt persistently, it grows taller and taller. The accumulating layers of lava push it upwards towards the sea surface. Eventually, after countless eruptions, its peak can rise above the waves. At this moment, a brand new island is born into the world. The beautiful Hawaiian Islands, for instance, were all formed in this very manner. Imagine the spectacle of new land appearing from the depths. Even after majestic mountains and new islands are formed, volcanoes continue their work. They are restless sculptors, constantly reshaping the landscapes around them. Subsequent lava flows can create entirely new stretches of coastline. They can also pour into valleys, filling them up. This sometimes creates vast, flat plains known as lava plateaus. Sometimes the top of a volcano can collapse inwards after a massive eruption. This forms a huge depression called a caldera. These calderas can later fill with rainwater or snowmelt, becoming breathtaking crater lakes. The Earth's landscape is always a dynamic work in progress, with volcanoes as tireless artists. Volcanic eruptions, with their fiery displays and flows of lava, can certainly seem destructive. They can transform landscapes in an instant. However, the ash that they spread far and wide holds a remarkable secret. This fine grey powder is packed full of valuable minerals. When this volcanic ash weathers and breaks down over many years, it mixes with the existing earth. It helps to create exceptionally rich and fertile soil. This soil is absolutely wonderful for agriculture and farming. Plants grow strong, healthy, and abundant in such nutrient-rich conditions. Around the globe, many regions blessed with volcanic soil are famously green and lush. Consider places like Indonesia, with its terraced rice paddies, or think of the fertile volcanic slopes of Italy where grapes for wine flourish. Coffee, tea, fruits, and a vast array of other crops grow exceptionally well in these areas. The incredible richness of the soil comes from essential elements. These include potassium, phosphorus, and many trace minerals released by the volcanic rock. These are vital nutrients that plants need to thrive. So surprisingly, a volcano's fiery breath can lead to great agricultural abundance. However, volcanoes also have a significant impact on our atmosphere and air quality. When a large volcano erupts powerfully, it sends more than just ash into the air. It also releases vast quantities of gases. These gases include water vapor, carbon dioxide, and notably sulfur dioxide. This sulfur dioxide can react in the atmosphere to form tiny sulfate aerosols. These particles, along with the fine ash, can affect the air we breathe. This is especially true for communities living close to an active volcano. The fine ash particles can travel for thousands of kilometers, creating hazy skies. Sometimes air travel has to be suspended because these ash clouds pose a danger to jet engines. The impact of very large eruptions can even extend to our global climate, at least temporarily. When enormous quantities of volcanic ash and sulfur gases are injected high into the stratosphere, they can act like a giant sunshade. These particles can spread around the Earth. They reflect a portion of incoming sunlight back into space before it reaches the surface. This can lead to a slight cooling effect on the Earth's overall temperature. This cooling typically lasts for a year or two after a major eruption. It dramatically shows how interconnected volcanoes are with our planet's complex climate system. The study of volcanoes is a fascinating and vital field of science. Scientists who specialize in this area are called volcanologists. They dedicate their lives to understanding how these incredible natural structures work. Their research helps us to learn about the very composition of the inside of our planet. Volcanoes act almost like windows into the Earth's fiery mantle and core. The materials they bring to the surface provide invaluable clues. These clues help us piece together Earth's long geological history. They teach us how our planet was formed and how it continues to evolve. Understanding volcanoes is also critically important for the safety of human populations. Millions of people around the world live in close proximity to active volcanoes. These communities face potential risks from eruptions. Scientists, therefore, monitor these volcanoes very carefully. They use a wide array of sophisticated instruments. These tools detect subtle changes that might signal an impending eruption. Such signs can include ground swelling, increased gas emissions, or small earthquakes. This continuous monitoring allows them to issue timely warnings. Early warnings can provide precious time for people to evacuate, saving countless lives. Beyond their scientific importance and the need for risk management, volcanoes also offer potential resources. In many geologically active volcanic regions, we can harness geothermal energy. This is the natural heat that emanates from deep within the Earth. This heat can be tapped and used to generate electricity in power plants. It can also be used directly for heating homes and businesses. Geothermal energy is a clean and renewable source of power. It does not produce greenhouse gases like fossil fuels do. It represents another way that volcanoes, these powerful forces of nature, can benefit humankind. In conclusion, volcanoes are a fundamental and awe-inspiring part of our living planet. They are powerful agents of both creation and destruction. They build mountains and islands, enrich our soils, and can even influence our climate. They serve as a constant reminder of the immense power of nature. By studying them, we not only gain profound knowledge about Earth, we also learn to respect their might. Crucially, we learn how to live alongside these fiery giants more safely and sustainably. Understanding volcanoes helps us to appreciate the dynamic Earth even more deeply. It allows us to better protect ourselves and our shared future on this remarkable planet.